could be, there's a kitchen going in here, if you can just imagine a kitchen. There's a bathroom and laundry, bedroom down there. That could be a bedroom, but it's also set up as a media room. And then upstairs, you can see the plan here anyway. The upstairs is really the other half of the house, or it's a much bigger part of the house up there, and an attached garage. So I think what's really evident here is you can have big windows and have a nice view. The view from upstairs is going to be amazing because you've got so much glazing. And because we're doing the high performance triple glazed windows, that's okay. So you don't necessarily have to have small windows to have a Superhome and have a thermally efficient home. Same with the little house there in Prebbleton that had, that's a passive house certified low energy building. But if you get the balance right with the rest of the elements in the building, you can have a good amount of glazing if you want to open out to the exterior, take in the view. Even that house there, it's got a nice aspect. So you can have that sort of indoor-outdoor flow if you want to. So these windows, they're from Poland, Kaufman windows. This house here in Ireland was the first house we used these windows in. They're approaching R2 thermal value. So, you know, R values, that's a wall. In New Zealand Building Code, R2 is the wall. So typically, windows are 0.5, so they're 4 times as good. And they're beautiful. So this house is actually going to be available to see on the 6th. On the 6th there's a bus tour. It'll be a lot further along and the windows will be installed. On the 7th there's a pop-up tour where you can come back and see how this has progressed. But yeah, so the other key features are the super insulation. Just on the table behind there, this is indicating the roof. Here, the timber panels that you can see upstairs, they'll be left exposed. So that's the structural ceiling. So this is only sort of indicative that the ceiling's thicker than that. It's about 160 thick. And it's also the finish, but the insulation goes on top of that, and this is just flat, but it's actually shaped to the fall of the roof. And then there's a membrane on top of that. Sealco are doing that's called a warm roof. And the beauty of that is there's no thermal bridging because the insulation's continuous. The other cool thing about the cross-laminated timber panels is because that's your finish, if there's an earthquake, well, first of all, it's incredibly strong in an earthquake, but if there is an earthquake, you don't have to worry about cracking of the jib because it's not jib. You're not going to get that. So we've thought about, with this house and all the houses we do, we think about the earthquake resilience and designing them so that they're going to stand the test of time. It's probably not if there's going to be another earthquake, it's when. We're living in the shaky Isles. So that's important. The other things, obviously, Superhome, a lot of it is about the thermal performance. So there's a bunch of these over here, but if you've got one of these are it's not all of the things you need to think about, but it's sort of the top 10 things. And top of the list is design. So thinking about the design in terms of the size, orientation of the windows, the orientation to north. A lot goes into that. So it's not just about the thermal heat loss, but it's also about the structural bracing. So when you're thinking about the proportions of the windows and the placement of the windows, you've got to have a certain amount of solid wall to make sure that the house is going to be strong enough in an earthquake. So the house in Prebbleton that I was at this morning, that was 5-star Quake Star rated. So Quake Star is a tool for rating homes. It was originally developed for commercial buildings and later for residential. So there's a website, it's free to use, it's called House Check. So you can just go onto there and put the details in for a house and it'll tell you how that's going to perform in an earthquake. So really, the next thing that we're thinking about is the materials. And so that house is zero energy. So it's energy positive is another way of saying it. So it actually uses less energy than it produces. So I was talking to Paul, the owner, this morning, and his power bill was $150 for the year. So not per month, for the whole year it was $150. But that was also powering that $150 for the whole year power bill was powering an electric vehicle going from Prebbleton to Christchurch. So if they didn't have an electric car, then they would be making money from the solar. That's 18 solar panels. So that's that house there. So that proves to us we can do an energy positive house. Our next target that we're currently working on, we're about to start building a project which is carbon neutral as well, or New Zealand's first carbon negative superhome. So what that's about is thinking about all the materials that go into the build and making the right choices. And we're using a program called VQuest and working with a company called VQuest who are helping us to calculate the carbon. So that's been a real eye-opener and a really big learning curve, just helping us to identify the materials that have the least embodied carbon. So using things like, in that particular house, we've got a timber floor instead of a concrete floor, so there's less carbon. We're using timber cladding, which is totally recyclable. The offcuts you can just chip up and you can put it on your garden. And it's actually carbon negative. So the timber panels upstairs, they look great, they're structurally great, but they're also sequestering carbon. So there's a lot of embodied carbon in that timber. And the concrete that we did use in this build, we used fly ash additive to replace some of the cement. So it's actually 40% less carbon in the concrete that we're using. So concrete's getting better and better, and the concrete manufacturers are working on how to make it better all the time. So, it's seen as a bad material in terms of its embodied carbon, but it's getting better and better all the time. And we can't not use it. We've just got to do the best we can and use it wisely. So I guess the other aspect of a superhome is it's got to be aesthetically, have some aesthetical flair, and I'm not going to deny that, that's quite high up in our priority, just thinking about what looks good as well as all the other important considerations. So I think there's a winning combination. It's performance and it's aesthetics. And some of that actually crosses over into thinking about biophilic design. Sounds like a scary word, biophilic, but I prefer to say organic architecture. But that's all about just thinking about how the design is incorporating nature and referencing nature and natural materials. So that timber ceiling is a good example of that. Just having the right outlook and the right windows and bringing the landscape in, even if you've got a small size home and you've got the windows in the right place, you sort of borrow the outdoor space and you create a space that's actually might appear to be bigger than what its footprint would be saying it would normally be. So some of the smaller houses we've done are really good in that regard, and creating a higher ceiling. So this house has a higher ceiling too in the living room. So that has a real influence on making a house, even a smaller house, feel more spacious if you've got some volume. So there's all these tricks that you can adopt that help be more efficient in terms of space. And here I am saying this in a really big house, but ironically, but yeah, I think that's really important. It's a really good place to start because it's really expensive to build any house today. If you can be more efficient in terms of your footprint and then you're going to use less materials, it's going to be more affordable to build, it's going to be more affordable to heat and maintain and all of these things. So you can put more, if you make it, eliminate the waste space, make it more spatially efficient, you can put more into the quality. And that's our starting point. The small house in Prebbleton, there's no hallways. So nobody's come to me and said, Bob, I want you to design a house. Can I have more hallway, please? You know, if we just get rid of the hallways and make the house so it flows and plan it really cleverly, then that's just space that you're paying for that's not utilisable. If you just eliminate that space, it's a good starting point because everybody's on a tight budget. So base, better, best are our levels of Superhome certification. If you are on a tight budget, base would be what we would consider as the minimum standard for a healthy, sustainable home. And then you can choose to do better or best based on your targets, what you're wanting to achieve, and also what your budget is. So we're introducing monitoring in all of those super homes. So a lot of the homes that have been finished recently have little sensors in them so we can monitor the performance. So after a year of monitoring through all of the seasons and comparing that to the energy use, we can tell whether that house is performing to the Superhome standards. Really easy, really efficient way of doing it. And that's useful particularly for existing homes. And we're doing a home at the moment where we're doing a renovation. So we're monitoring it before in winter, and then afterwards we'll be able to compare the improvement in performance after we've renovated it. So all of the homes on this year's tour are new homes, but we're really interested in renovations and helping people that may not be able to afford a new home, but they need to improve their home because we've got 1 million unhealthy homes that are just energy hungry, and if we're going to reach carbon zero by 2050, we've got a massive task ahead to renovate the existing homes because there's 80% of the homes that will exist, that are being in existence in 2050, are already here today and they need to be improved. So we're doing design guides for updating our Superhome design guide, and we're also doing a Super Reno guide, which is some of the same principles, but it's always a bit more challenging to do renovations because it depends on what you're starting with, what's the age and type of house that you're working with from the beginning.
Would you say that the principles set in the last 10 years in terms of super homes haven't changed? It's just that the materials and the products are getting better?
Yeah, I think so. I think we're always learning too. So the materials are getting better and more materials are becoming available, but just our knowledge is getting better too. So, I mean, I've been on this beating this drum for like 2 decades or more, you know, and my home that I repaired after the earthquake, I thought that was quite good when it was designed and built. We designed it, and it was 3.5 years old at the time of the earthquake. And it was what I would call an energy efficient home back then. But with the renovations that we did a warm roof like this, we did exterior insulation, we put triple glazed windows, we improved that home from, the power bill was halved and the thermal comfort was improved massively. It's just 21 degrees the whole time with half the power bill that it had before. We put ventilation in, so it's got a really nice quality of air. We basically did everything we could. So you can, depending on the home, there's no one shoe fits all, but some homes more lend themselves to renovation better than others, and some homes they might be too far gone. So the first thing is to do a thorough assessment of what it is, is it renoable, or is it not worth it? And but yeah, there's a lot of things you can do depending on the age and type of the home.
Well, you mentioned the materials that you used in this home and others where you have added not much to the material. So the timber settings you mentioned are actually part of the structure of the building as well. You use them as a finish, and there's no jib board on them, so that you talked about earthquake security. But there's also the fact that you don't need to paint them and stop them and repair them constantly, so there's a reduced long-term cost in doing it, and similar with concrete floors.
Yeah, absolutely. So just thinking about the longevity in terms of finishes is really important. You know, like in terms of embodied carbon, funnily enough, carpet is really bad because you have to replace carpet several times through the life of the building, and it's actually quite a lot of embodied carbon in doing that.
And the health.
And you can get dust mites and allergens and that in the carpet. So, but you know, the trend, I guess, just generally is aesthetically is towards hard flooring, timber flooring, and that sort of thing, which is actually good in terms of the carbon too.
So, with the biophilia and so forth, and all the considerations that you're now putting into the design department, is that making you more conservative as designers? Are you not doing any sort of zing-zang, sort of daring design buildings because of those considerations?
Not at all. It's probably actually making us better designers, and it's not cramping our style at all in terms of creativity. I think in the past perhaps some things have, like for a while we were doing a lot of French doors, hinged doors, because they're a lot more efficient, a lot more airtight than sliding doors. But now you can get really good sliding doors in New Zealand. But and so we're moving back to the large sliding openings and things because those products are available. So there's a little bit of that. We suffer a little bit because we're at the bottom of the world, and there's a lot more products available where there's a bigger population base. But you know, these windows here, they're imported from Poland, and so we've got these starting to get these options now, and it's actually opening up our design options and what we can do. But yeah, I guess in terms of just this next hurdle that we're sort of up to our neck in at the moment, thinking about the embodied carbon, it's meaning some of the materials that are nasty, we're having to stop using them. And if we can't get the data, it's another hurdle. So if there's not an environmental product declaration or EPD available for a particular product, then we've just got to move on and select a different product because we need that information to be able to calculate the carbon footprint. So yeah, there's kind of different sort of horses for courses. There's different aspects to it. But, yeah, and I think the thing I love about Superhome movement is we're all just learning from each other, sharing ideas, and everybody's really generous. And you know, that's what the tour is about. And you know, we're just learning new things each time we do a build that's better than the last one because we've learned a new, more efficient way of doing it, or learned about a more cost-effective way of doing it, perhaps.
But how much are you doing all of this wonderful stuff just for the rich? That it doesn't, you haven't, I'm not sure if you have or not, but brought down the cost of building a home for people who might not have money.
Yeah, I think it's probably a bit of a myth that it's too expensive to do a home that's better than building code. There's a lot of things that you can do that are actually cheaper. And I'm just looking around, but there was a brochure there before about jib fixed framing system. That's a really good example of something that costs less, which actually provides better performance. So the idea of that is you just have less timber framing in the wall, so you don't have the dwangs in the exterior walls anyway.
Like your upstairs example.
Yeah, like upstairs, and then you don't have extra studs at the corners and where a wall joins a junction between an internal and an external wall. So you do away with that timber and you just fill the wall up with insulation. So timber's more expensive than insulation. So effectively, that's cheaper. So you're saving money. And there was a research study done a couple of years ago which found that in New Zealand, the average amount of timber in a wall is 34% of timber, and the rest is in insulation, the timber insulation ratio. Before that, it was assumed it was 14 or 14 to 18, I think. And it can be even higher than 50%. So that's really reducing the thermal performance of the wall quite a lot, and it's unnecessary. Probably if you're going to remember anything about what you've learnt about today on the Superhome tour, it's don't trust the building code. So we need to do much better than the building code. It's about 2 decades behind. And even, I don't know, you might have noticed in the news this week, the Minister for Building and Construction is talking about winding back the new improvements that were implemented to insulation values last year. So that, in my view, is ridiculous. Hey?
You saw the pink.
Yeah, that's a great cartoon, yeah. But, I mean, if we're going to cut Mr. Pink a break, maybe he's just been fed the wrong information, and yeah, because, you know, it's a few builders saying that insulation actually stops heat. It doesn't make a house overheat. So it'll work both ways. It'll make it warmer in winter and it'll make it cooler in summer. What causes overheating is a faulty design. So having too much glazing facing north or west and not having the right amount of shading. So if you look upstairs, you'll see there's a 2 metre overhang on the roof. I mean, these are massive windows, but that's a massive overhang. So this house is going to be very well protected in terms of shading. There's also these windows, these beautiful windows from Poland. They have built into them, there's an option for shutters externally, or there's a roller blind which has a certain amount of opacity, so it blocks different fabrics, block a different percentage of sunlight, so you can still see through it, but it's actually providing you some really good external shading. So shading has to be on the outside of the windows. It's not going to work on the inside. So pulling the curtains, too late, the horse is already bolted. The shading's got to be on the outside.
Is there a ventilation system?
Yep, so this house has a ventilation system. Marcus over there just did a talk about the ventilation system. So talk to him later about the ventilation system. So this is why we've done this ceiling here with these beams, so we can get duct work through here. Actually, we've worked out how to get ducts into air into every room in this house. Wasn't easy, but with the roof design, but we worked it out. There's a few bulkheads there and there. And Ben's grinning. Ben, the builder, will know all about the pain of doing that. Yeah. So yeah, even my own home, that didn't have ventilation in it, and it was difficult to fit the ventilation in. But where there's a will, there's a way. I have a saying: if in doubt, bulkhead it out. You know, you can put the ducts in. Bulkhead Bob. Yeah. There'll be a way to fit the ducts in, and if you can't, there's decentralised ventilation options. So you can have a unit that might extract from one bathroom and maybe a couple of bedrooms, if you can't get the duct work to one end of the house or something like that. But the ventilation is really important, particularly with these airtight builds. Once you get an airtight house, you've got to have ventilation. You've got to extract the moist, stale air and get rid of the toxins and bring in fresh air, because even though it's invisible, we can't see it, the air inside our homes is often a lot worse than the air outside. And CO2 builds up. Humans breathe out CO2. Humans breathe out moisture. If there's no ventilation, that's just going into the walls and potentially creating a situation where you could have condensation and where mould could develop inside the construction. So ventilation has a dual purpose. It's making it healthier, beautiful air quality that's healthier for people, but it's also protecting the building as well. And, you know, if the building deteriorates, then that can cause serious health issues with black mould and that, like asthma and these sort of things that we have in New Zealand at much higher rates than a lot of other countries. 30,000 kids get admitted to hospital every winter in New Zealand, and that number's climbing year on year.
So why worse than other countries?
It's because of our housing. It's because of our poor housing, uninsulated homes, and poor building code standards. And it's not just the old homes, it's recent near new homes can have condensation in them. In fact, it's become expected. We just put up with it. We think it's normal to have weeping windows and have condensation in our homes. Other countries, it's illegal. And we need to get there. So that's our mission with the Superhome movement. Just point out what's missing from the building code, help people, as many people as we can, to do the right things.